Chapter 7 was absolutely awesome with absolute values. So, I don't know if you guys see absolute values anymore in middle math, but remember they're just those lines. So this is not 100 and negative, so this isn't 100 negative 7, 1. Right, it takes any value and just makes it positive. Okay. Right, like if you had something like this. Oh, wrong bracket now. Like if you were to solve all this, the absolute value is the very last thing you do. So if you remember bed mass, brackets first, then exponents, multiplication, then addition. Right? Yeah. Yeah. Bingo bongo. Hey-o. Okay, so that's like 7.1, 7.1. So yeah, if you were to actually graph absolute values. So if you had a function now, let's say of 2x minus 3 with absolute value signs around it. So what I always do with these is I graph the original and then I just change it. Well, you could. But this is y equals mx plus. Oh, did you guys just use a table of values? Oh, lame. Okay. Do you guys remember y equals mx plus b? This is your slope. This is your y-intercept, right? Your slope, steepness of the line, rise over run. Right? So, to graph this cool cat, oh, do you guys, table of values suck. This is why you guys got so far behind. Okay. That's fine. She did a great job. Everyone learned a lot. We had a good time. That's all that matters. Thank you, Levi. Let's get that on the record on YouTube. Okay, now, with this one, my B value, do you guys remember what that is? What? Yeah. Yeah, your y-intercept. Good. Okay. My y-intercept should be at -3, right? My slope is 2 over 1. Remember, that's rise over run. So you go, well, whatever is in front of your x is your slope, right? And you learned it in math last year, too. You just did, D. You totally did. I guarantee you I taught you y equals mx plus b last year. You're not multiplying by multiple things. No, not at all. But you plug it in. Okay, so rise over run, so that means you go up 2 to 1, -1, and over 1. So that's my original graph there, okay? But because this is an absolute value function, it's going to take any values I get that are negative and make them what? So instead of -3, the actual value would be at, very good. So then your actual line looks like this. If you wanted to get real cheeky, you could tell me what the x-intercept is at. What? Yeah, it reflects off the x-intercept. What's the y value on my x-intercept? Right? So if you wanted to, you could go back and say 0 equals, and solve for x. So you bring 3 over. X equals 3 over 2. Boom. That's how you graph these things. Easy peasy lemon squeezy, right, D? See, for the record, Danita said yep. Questions about that? Do you look a little stressed? Is it bugging you that I'm not using the table of values? Right? So tell me if this looks familiar. So it's the regular function if x is greater than 3 over 2, and then it's the absolute function if x is... Okay, and I will have to take that off the file. So if it's x is greater than 3 over 2, so this part here, you would use the regular function. And then if it's less than, you would use the absolute. But if you guys haven't seen it, I'll have to double check her assessment here, but I don't think she had it on there. So. Yeah. Yeah, that's all it's saying. You guys want to see another linear one, or do you want to do a quadratic? That was with certainty, Dunedin. I like it. Let's do... Yeah, straight line, linear. So we're going to grab this big old quadratic. Yeah, I would. Yeah. So all I can tell from this right now is my y-intercept is at 0 and 8. And I know my graph is going to open downwards, right? It's going to bounce up. So first thing I need, though, are my x-intercepts, because that's going to tell me where the graph is going to change, right? Because that's where it goes from positive to negative. So to do that, I just take the original function here, and I solve for the x-intercepts. One of two ways, quadratic equation or factoring. I'm an adult, so I'm going to factor. And then you take out the -1 and you can factor it quite easily. Uh, oh, -4. Sorry, and -2. And +2. Yeah. So my x-intercepts then are at 4 and -2. No, no, don't use that a value for anything. Okay? That, yeah. Common mistake, but yes, but you don't have to. Yeah. Like you could factor it like this without taking out the -1, and you'd still get the same answer at the end. You would end up with like, yeah, yes. Yeah. That's quite literally what I'm going to do. So, my original function now. -2. And 8. Beautiful. Now, I can't have anything below the x-axis, can I? Right, so it's actually going to do this. You can just draw the W. Okay? It's totally up to you. I don't penalize you for both. I do ask, though, like, if you're drawing this one here, do it in a pen or a pencil, and then do the actual one, and then label it too. Like, tell me what it is. So this is the actual. Yeah. Like this one is -x². Like that. One doesn't have the absolute values. This is the absolute value function. This one doesn't have the absolute. Yeah. No, just label only what you draw. And that's how you graph those. All right, how many? 13 minutes. Okay. Yeah. We have a law test today? Is law all year or half year? Wow, that is. Oh, yeah. So it's more of a grind up front. Gotcha. Did you guys, so absolute functions, I should say value. Woo. I was riveted by your law test story, so I got sidetracked. So you had to solve riveting stuff. Well, no, you got to solve, like there's an equal sign. So you got to solve for x. You got to split it into two. So like you have this, or like that. Because with an absolute value function, the answer can either be positive or negative. So you split it into two. You guys remember this? Yeah. No. Let's see here. No, she did not do that with you guys. No, it's fine. All right, never mind. We won't do this. It's a little frustrating. That's fine. No, it's not. It's not your guys' fault at all. I'm not mad at you guys. And I'm not like even like, when parents say I'm not mad at you, I'm just very disappointed. I'm not even water off duck's back over here. No, it's not your guys' thing at all. Okay. Reciprocal functions. You guys did this because I just saw it on there. No, reciprocal. Sorry, I should write that down. Reciprocal. Okay, spelled it right. Nice. Hey, he's coming up. Whatever. I know. I barely teach I don't even teach the 12s next semester. So. Jameson, she'll teach the chemistry. Yeah, that's super awesome. What are you doing that for? Oh. Well, that'd be cool. That was a nice break. That was infuriating. They should be in phys ed. Okay, so let's start by graphing. So this one again is y equals mx plus b, right? So my y-intercept is at what? Very good. Okay. And we should also plot the x-intercept now. Okay. Yeah, so with reciprocals and absolute value functions, finding the x-intercept makes your life a lot easier. Yeah, hopefully I don't need to show my math for that. Excellent. So that's just 2.5. So my graph would look like this normally. That's bad. That's better. Okay. But now, if I wanted to graph the absolute, or the reciprocal of this, right, it takes your big numbers. So like this one here is at 0 and 5. So it takes all your y values and flips them. What's the reciprocal of 5? No. 1 over 5. So now it's down here. Okay? And also, so this one here is at 5 over 2 and 0. What's the reciprocal of 0? No. 1 over 0. Think about 1 over 0. It doesn't exist. So do you guys remember what goes in place of that? The dash value. This line has got a special name. It is called an asymptote. Yeah. Right, it can't be that. Well, because once you put a 1 over it, it changes everything. And this is actually helpful for you guys taking Pre-Calc 30 next year. Then you don't take it? Are you taking Foundations 30? Yeah. That's up to you. It depends on what programming you're going to go into. Like if any of you are thinking university, I would definitely encourage Pre-Calc 30 and Calculus 30. Because if you take Calculus 30 in high school, it makes Calculus in university, like beginner calculus in university, it's the exact same class. It's so easy. So you can like take your energy and focus it in on your other classes that are hard and have an easy math class. Makes sense. And Calculus 30 is way easier than Pre-Calc 30. Yes, Mr. James. Oh, I didn't update PowerSchool. It's Dunedin's fault. She snuck in. She snuck in when I wasn't around. We all saw her like just creep in, right? Okay, so let's graph this. So my graph would come across like this, but it can't cross the asymptote, right? So it goes. Right. Let's do a quadratic. Why? It's up to you guys. I always just plot the x and y intercepts and just. As long as you have the asymptote and the y-intercept in the right spot, I don't care. Yeah, it's too much time. All you need is a sketch in math. Yeah, it takes too long. Like, I know math is all about precision, but if you can be precise with a few points, your sketch is fine. Okay? Never did I have to, like, precisely plot 5 points and then connect them all. Yeah, it's ridiculous. Like, once you get to calculus, guess what you learn to do? Curve sketching. Sketches. You only need a few key points and then you draw the rest. All right? No. No. Okay? So, let's graph this one. Well, where's my y-intercept? Very good. Is that 0, -6? So at the reciprocal, it's actually going to be at 0 and 1 over. Right? Now let's find the x-intercepts. So this is the big one. This is where you're going to get your asymptotes, right? Yeah. It's at the x-intercepts. Yeah. Yeah. It's just, this whole thing's just negative. My x-intercepts are going to be at -3 and 2. Yeah. So these will be where my asymptotes are for the actual. If it helps, I find with the reciprocals to graph out the original. So if I made a sketch, where they meet. Oh, yeah. The line of reflection. So my original graph would be at -3, 2, -6. Something like this. Oh, look at that. Stuff is sticking. Now, to draw the reciprocal of this. What happens at my x-intercepts? Yeah. No. Have we ever graphed asymptotes up until now? No, so clearly it's only for now. No. With me? No. Never have you ever. Oh, yeah. That's linear optimization. Doesn't matter. So, my original x-intercept was at -6. For the reciprocal, it's going to be at -1 over 6. So it literally just takes this and flips it up, right? So my graph now does this. Yeah. And then the rest of it, yeah. And then this one, instead of heading down towards the asymptote, it heads up and away. Instead of like this, it does this. No, those ones you can just, because these lines here, what they're doing is they're running off to infinity this way, and they're running up to infinity that way. So I don't care about points. They're just going forever. Depending if it's above or below, but no. All I'm interested in is where it crosses x and y intercepts. Okay? No. No, why? See, that's ridiculous. Why? It's such a small, minuscule number. Yeah. If I have time to get to that. You might have to come at lunch for that one. Okay. Okay, this is a real butchered. Okay, now are you guys okay with substitution and elimination stuff? It would have been what you did in chapter 8. '17, like 1V. Yeah, there were quite literally 2 points to it. Yeah. Subtract them. Like if you had something like this. Yeah. So like if I was this one here, I would do substitution. Right? I would switch this around to be I'm gonna bring this here and that there. I would say y equals 14 minus 4x. Then I take this here and substitute that in for y there. So it'll look like this. X squared minus oh, 4x. Oh, sorry. We'll get there. Yes. Negative switches everything. That's the hardest thing in math. What's that? Because this was positive 14. Right? Positive 14 minus 4x. So it makes it. So now you factor this. Positive 6 and negative 2. So then you have two solutions, right? So you plug that in and solve for your y values. Do you guys remember that? Yes, yes. Seriously? Or you just want me to be done? Okay, so I solved for my x values now, right? So now I need to plug that back in to get the y value. So I plug it into the easier of the two and solve for y. This is what they have in common. Yeah. So you would do like y equals 14 minus 4 times 2, and then you would do y equals both. Yeah. Well, twice. 1, 2. Because like what this actually looks like is you have. No, just take the 2 and put it into one of them. Don't do both. No, I'm sorry. I thought you meant like both x-intercepts. No. Yes. Okay. That's positive 24, 38. So like this is what it looks like. You have a parabola and a linear equation, and they cross at 2 and 6. Oh, I graphed it totally wrong. Negative 6 and 38. Okay. You don't have to graph them. I'm just showing. This is me giving you a visual so you understand it better. So I'll give you a few of those to work on. Just a few. Like there's not going to be a lot of them on the test. There's no time. D. There's no time. Yeah. No time. We did that already. Maybe you weren't here. I thought I sent you a video. Okay. What's that? Yeah.